Today, for our final lesson on the periodic table in this unit, we're going to look at the difference between atoms, isotopes, and ions. Hopefully you recall that an atom is what you find on the periodic table. An isotope is an atom with a different number of neutrons in its nucleus. And so all we need to do is look at what an ion is. So, ions are atoms or groups of atoms with a positive or negative charge. So they're no longer a neutral atom, they now have a positive or negative charge. How are ions created? So ions are created when a neutral atom is unstable. In other words, its outermost energy level or its number of valence electrons, its outer energy level is not full, its number of valence electrons are not 8. And so therefore it's unstable and it's going to bond with another atom. And in doing so, it's going to lose or gain an electron to complete its outer level. So an octet of 8 electrons makes that outer level stable, unless it's hydrogen, which can only hold 2, and helium, which can only hold 2. So that would be a duet. So you've got several different types of ions. You've got positive ions and negative ions. So let's look at the positive ions. If you take away an electron from an atom, then it makes it a cation with a positive charge. And what that means is that it now has more positive protons in its nucleus than it has negative electrons surrounding the nucleus because it gave away an electron. So if it gives away 1 electron, it becomes a +1 cation. Now there's a very simple way to figure out what's going to happen, whether or not it's going to be a cation and what charge, or whether it's going to be a negative. Cations are metals. All metals are going to give away an electron when they bond because they just don't have that many outer valence electrons because they're in groups 1 through basically 13 or 3. And so they just don't have that many to give away, and it takes a lot less energy to give away those 1, 2, or 3 to make their next inner level full than it does to try to get out here and get 7 or 6 or 5. So all metals are going to become positive. They are going to give away electrons. Now an easy way to remember this, if you make little pause, you can say that a cation is positive. Okay? So remember that all metals are going to lose electrons, becoming positive cations. And you can tell if they're going to be a +1, +2, etc. because of the group number. So if they're in group 1, they have 1 valence electron to give away. That means they're going to become a +1. If they're in group 2, they have 2 valence electrons to give away. That means they're going to become a +3. 2, my bad. And I'm sorry. All right. And so on. So now, adding electron to an atom gives it that's called an anion. It has a negative charge. This means that it now has more negative electrons outside of its nucleus, because it took some, than it has positive protons inside its nucleus. So to tell the difference between an atom and an ion, all you have to do is look to see if there's a charge in the superscript. Right here, superscript is above, subscript would be below. So Na is sodium, and it's in group 1, and it's a metal. So Na is a +1. Calcium is also a metal. It's in group 2. And so it's going to become a +2, giving those 2 electrons away. Now, all of your non-metals become anions because they take those electrons. So they have an excess of negative charges. Now, iodine is in group 17, and it needs 1 electron to be complete. So it becomes a -1. Oxygen is in group 16, and it needs 2 negative electrons to become full. So it becomes a -2. So there's a big difference between cations. You're looking at how many they give away. That becomes their charge number, those metals. But with anions or nonmetals, you're looking at how many they need to be complete, and that will be their charge number. Okay, so a cation forms when an atom loses one or more electrons. So this is magnesium. It has 12 protons and 12 electrons, and I can tell you that it is in group 2. So it is going to lose 2 electrons, becoming a +2 charge. All right, an anion forms when an atom gains one or more electrons, like this fluorine. Fluorine is in group 17 or 7. It needs 1 electron to be complete, so it now has a -1 charge. How to remember if an ion is a cation or an anion. So if an atom gives away one or more electrons, it becomes positive, like cat paw. So for example, if it gives away 1 electron, it becomes a +1 ion or a cation, meaning it has 1 more positive proton than it has negative electrons since it gave that one away. Now, an easy way to remember this is that if it is a metal, it is going to lose electrons. So if you look at the periodic table and you see that the element you're looking for, like magnesium, is in a metal, then you look at what group it is in. And whatever group it is in, that tells you how many valence electrons it has out there, and it's going to give those away. So like magnesium is in a group 2, so it's going to lose 2 electrons, becoming a +2 cation. And all of your nonmetals, like fluorine, are going to take or gain electrons to become complete. So fluorine, all you do is you look at the periodic table, you can see that fluorine is a nonmetal. All nonmetals are going to gain electrons, and that means they have an extra 1 or more negative electrons outside their nucleus. So with nonmetals, you look at how many they need to gain to be complete, and that becomes their charge, because that's how many they took. So how many negatives they took. So fluorine is in group 7, and so it needs 1. So if it takes 1, then it becomes a -1 anion. So again, metals all become cations, they lose electrons, while nonmetals all gain electrons, become an anion. So you really just look to see what group it's in on the periodic table. Okay, if you look at the periodic table, you can see that all of the first group become +1. They're metals, +1. They have 2 valence, so they give that one away. 1 valence, so they give that one away. All of your group 2 are metals, and they're going to give away 2. But if you switch over here to your nonmetals, you can see that this is group 15, so it has 5 valence. It needs 3 to be complete. So if it takes those 3, it becomes a -3 anion. All of group 16 needs 2, so their number becomes -2, and all of group 17 needs 1, so they become -1. Here's how I like to read it: 1, 2, 3, 4. 3, 2, 1. So these right here, this is group 13, so they're +3, and group 14, all the metals in group 14 are +4, and this one nonmetal is -4, but it still reads the same: 1, 2, 3, 4, 3, 2, 1. And that's just an easy way to determine. Now, group 18 is full. So it's not going to it's not going to bond. It's not going to get a positive or a negative charge because they're stable, they're full, they're happy. The noble gases, they won't bond. Okay, so if we are in class, we're going to label these ions on the periodic table. And again, it would be 1, 2, 3, 4, 3, 2, 1. And that tells you the charge number just based on the location. And this is basically all that I have said, and if I were you, I would probably go back through and read these just to see, like group 16, nonmetals need 2 electrons to be complete, so they'll have a -2 charge. That means that all of the elements in that group will be -2 when they bond. Group 15, so your nonmetals, they all need 3. So when they bond, they're all going to become -3. So if they're in group 15, they become -3. It's just a very easy way of taking the group numbers and remembering that if they're metals, they're going to be cations or positive, and they're going to give away however many the group number is. But if they're nonmetals, they become negative, and their charge number becomes however many they need to be complete, like group 15, 16, and 17. Okay, so you have to look at how many they need based on their group number, and then throw a negative sign in front of it. Now, again, reactivity, we already touched on this, but because the cations in group 1 will only give 1 electron away, they are highly reactive to group 17, which only needs 1. So groups 1 and 17 are the most reactive elements on the periodic table. Okay, so state the number of protons, neutrons, and electrons in each of these. So for potassium, here's your atomic number. We've got 19 protons. We've got 19 electrons. And it's got a plus charge though, see? So that means it gains an electron, 1 electron. Well, see, this is a metal. No, I'm sorry, it's going to lose an electron, 1. So instead of having 19 electrons, it would have 18. So it would have 19 protons and 18 electrons. Let's look at oxygen. Oxygen has an atomic number of 8, so it's got 8 protons. But out here to the side, as a superscript, it says -2. That means that it gained 2 electrons. So instead of having 8, it is now going to have 10 in its outermost energy level. Okay, let's look at calcium. Calcium's atomic number is 20, so it has 20 protons, but it has a +2 charge out here, which means that it's giving away 2 electrons. So instead of having 20 electrons, it's going to have 18. Okay, write the nuclear symbol. I can tell you this is oxygen. It's 8 protons, so it would be O. And then the mass number would be 16, the atomic number would be 8, and the number of valence electrons, let's see, 2, 4, 6, 8. This would be a -2 if I drew it out. Hopefully we'll be in class, because otherwise I'm going to have to upload some drawing of some atoms to show you how this works. But don't forget that if you have a different number of protons and electrons, then that means you're dealing with an ion. So this is basically an atom because the protons and electrons are the same. This is also an atom. The protons and the electrons are the same. However, if you look at C, you can see that it has 1 more proton than it does electron. That means that it gave away, so this would be a +1 right here, okay? It's still the same atom. It's number 47 on the periodic table, but it's just got a different number of electrons, okay? So hopefully we'll get a chance to practice in class this list of ionic charges I'm really hoping, again, all you have to do is look at the group number and determine if it's a metal or a non-metal. If it's a metal, you put a positive sign and whatever group number it's in. If it's a non-metal, you put a negative sign